So you should have got the invite there if you want it. So we're jumping right in. Now we won't have threads finished this week either. We have another 2 weeks of these. So I know. I decided to treat you. I said I'd give you an extra week of threads. All right. Because I just looked them over there and there's more in it than I thought there's in it. So it'll be another 2 weeks before we have it finished. Right, so threads. Now I've already explained what threads are. Up here. So just to briefly recap, threads, you have different threads going through, threads of control going through your program. I am Iggy. Yeah, I am. Okay. So you have different threads of control going through your program. Now, up until EX14, it's all been single threads. All right. Now, that means you basically define the thread. You define your own thread. Okay. So all of these guys, new single thread. Now, the key there is the word single. That means you're creating one thread. So you're doing a series of tasks. They're all going to be on this thread. So when you're using single with an executor, that means you are creating the threads yourself. All right. So let's say you have 3 distinct parts in your application. One part is to deal with your database. One is to deal with your files. We have a couple more threads. Another one is to deal with your GUI. Another one is to deal with input from the user. Okay, so you can create 4 separate threads yourself. So one thread is going to control that. Another thread is going to control that. Another thread is going to control the GUI. Another thread is going to control the input. All right, so single. Whenever you use the single, that means you're creating the threads yourself. And those threads can be running beside each other. All right. Now, you can decide to let Java manage those threads for yourself. Okay. So you can create pools of threads. All right. So rather than creating the threads ourselves, we are going to create a pool of threads. Okay. So what they basically are is, you run your application. You're not going to say how many threads we're going to use. The previous example, we said there's 4 threads. Okay, so if you don't say how many threads it's going to use, you can use a pool of threads, which means that a certain amount of threads are going to be automatically created for you. All right. Now, the first type of, so it's a pool of threads. Now, it's not confused with the string pool, right? Don't get confused with that. The first one we create is a new cached thread pool. All right. Now, what that basically does is that creates threads as needed. That's what that does. Okay. That creates threads as needed. So it can create a lot of threads. All right. So if you have 4 different tasks, there could be 4 different threads. It could be 1 thread, right? You're not guaranteed how many threads are created with new cached thread pool. Okay. The second type, new fixed thread pool. The second type is you say, I am going to use 10 threads. Okay, you say, I am going to use 10 threads. And then the tasks are going to be divided out amongst those 10 threads. Now, again, you don't have to say what thread does what tasks. Whatever thread is available is going to do the task. Okay. The last one then is a new scheduled thread pool. Now, this is a thread pool that allows scheduling. Okay, remember what scheduling was? Scheduling was, let's say it goes every 2 seconds. Goes every 2 seconds for 10 seconds. Or it goes every 2 seconds while your application is running. In other words, infinitely. Okay, so now the scheduled tasks can be divided out amongst your pool of threads. All right, now, so those are the three different types of pools of threads. Up to this, we create our 4 threads, we create our 5 threads, and then we say what task is going to be done by what thread. This guy here, you have a collection of threads, and you don't say which thread does what task. Does everyone understand that? Okay, so that's the difference between a single thread and a thread pool. A single thread is you manage all the threads yourself, whereas a pool of threads, you've got a collection of threads, and any one of those threads could carry out their tasks. Now, all of the threads and thread pools are synchronous. Concordant, sorry, not. It's concordant at the same time, isn't it? It's concordant at the same time?
Yes.
Yeah. So all of these pools are concordant, which means if you have 10 threads, if you have 10 tasks, if you have 10 tasks, if you have 10 threads, all those 10 tasks are going to start at the same time. All right? So now I don't think we're going to get to it even this week, but the final section in this chapter shows you the benefits of threads. And I just ran it myself there last night. God, I have an exciting Sunday night, don't I? Okay. Oh, yeah. All right. So there's one example I have where I leave run it runs for a half hour. With threads, it's down to milliseconds. That's the sort of performance you can see with them, right? That's by factors of a couple of thousand, by a couple of 100,000. So that's what threads can do. Okay. Now, so we're going to go to pools. So a thread pool is a group of pre-instantiated reusable threads that can be used to perform any set of arbitrary tasks. Okay. Now, so you imagine we start off our program. Inside this is a cached thread. So a thread pool, you can imagine there's going to be, let's say, 15 threads in there that's going to be ready to be used. You know, like an array list automatically is of size 12. Remember that? Same thing. Now, I think the amount of threads in your pool does depend on your machine, as far as I know. Okay. I don't know how many threads are there by default. I think it's dependent on your machine, the amount of RAM you have, the operating system you have, the version of the operating system you have, the process load at the particular point in time. If your machine is doing a lot of work, as far as I know, there isn't going to be as many threads available to you. So there's a whole lot of variables in there that determines the amount of threads that are available at any particular point in time. Does everyone understand that? Yeah. So I think you can't say how many threads are available to you at any particular point in time because there's so many variables in there. But we'll just say 15. There's 15 available to us. Now, there isn't 15 threads in our program. It means that there's 15 threads there that can be used. That may or may not be used. Okay? Now, so down here. So we go executor service is equal to executors. Now, when you don't see the word single in it, that means it's a pool. Okay? So that looks like an exam question to me. All the other threads, doesn't matter how new single thread scheduled executor, new single thread executor, whatever. Okay? The key word there is single. All right? You can see all the other ones. It's single. That is the most important word in it. New single thread executor. This one here, you can see there's no single. All right, so this one here is new cached thread pool, right? Now, what this does is this gets a thread as needed, okay? Or another way of putting it, it creates a thread as needed. All right. So if I create a task, it gets a thread. All right. Now the disadvantage of this one is you can end up with a lot of threads. All right. You can end up with an awful lot of threads, which isn't such a good idea because then your application is trying to manage all these threads. No, not the new cache thread pool. No, you don't. Okay. With the other types, you do. Right? So new cache thread pool, you don't have control of how many threads are used or created. How many? You know how many at the end. Okay. But you don't know, you can't know at the start of it how many are going to be used. Now, usually the way it goes is, unless usually it's going to be one task per thread when you're dealing with not many. But let's say if you had 1,000 tasks, you're not going to have 1,000 threads. You might have 70 or 80 threads. You might have only 10 threads. You might have 5 threads. Now there is ways to manipulate your thread scheduler, but I don't know how to do them, to be perfectly honest. And also, these are not the thread pools you use in reality. Okay? If you have a very, very small application and you only want to do, now what it says here is, if you have only certain tasks that are going to go like that, run once, let's say you have 10 tasks that are only going to be run once every hour, something like that, then you could make them a new cache thread pool. They just go like that. All right. But if you have something that's going on continuously, something that's running every 5 seconds, something that has to be running in the background continuously, you won't have a new cache thread pool because it could be creating threads all over the place and it's trying to manage them. And you're going to see any gains in speed is going to quickly go down because it's managing potentially hundreds of threads. All right. It might be fine in this machine, but remember, how it handles threads is totally dependent on the machine the application is running on. So let's say you run it on an Android, a new Android phone, no problem. You're running on an older Android phone, then you're going to have a problem. Okay. Or if there's a lot of applications running on your phone at that particular point in time, you go to use this application that's multi-threaded, loaded threads in it, it's going to be slow. So your application that runs threads depends on how much memory is available to this machine as well. Okay, so threads are dependent on the machine you run it on. All right, now this one here. So this is going to basically create threads as we need them. All right, now, so I run it and it runs fine. Now, to show us that what's actually happening, I'm going to modify this code slightly. Okay, just put it in here. Now, let me just see. Now, I don't have any sleep inside here. Okay, so we can see here, I have, this is my service. So I have service, I have a submit on it. This is submit that takes a callable that returns null. This is a submit that takes a runnable. This is service.execute, which also takes a runnable. So they seem to run concurrently, or they seem to run one after another. Okay, now I'm going to put in, at the very start of each one of them, I'm going to put in a time check. Okay, so at the start of this one, I'm going to say time in first submit is local time now. And in this submit, No. Hold on a minute now. So I need to do service.submit. Time in second submit is now. And what did I put in there? And I'm going to put in plus count. And I'm going to say time in first runnable is now. Now, so because
you want to make that
a runnable, or sorry, callable. Callable. Okay, because the submit can take a runnable or a callable. Yeah, so sorry. This submit takes a callable, which has to return something, even null.
Is it going to be any different than runnable?
No, it doesn't really. all it's for is returns a object. Okay, and this one here, this submit takes a runnable, and then we have this takes a runnable. Or sorry, this execute. Execute always takes a runnable, but a submit can take a runnable and a callable. Right, so now this is EX14, so I'm going to run this guy. So I've done a time check in each one of them. So I want to see what the time is when the three of them start. Okay, so I'll go to here, EX14. Now, see the time. They all start at the same time. Okay, they all start at the same time. Now, so they run at different rates from that point onwards. Okay, this one is going to take longer to do, but they all start at the same time. See, that one starts at 260. That one starts at 260. That one starts at 260. Because they're running concurrently. All right. So they all start at the same time. Okay. Now you can see as well the order of things is all over the place. All right. Now, if these were running in order, it should say time and first submit. Then it should say submit task 1. Then it should say I is I. It doesn't say it till down here. Okay. And also, I doesn't get as far as 5 million. It gets as far as, it actually goes beyond 5 million. It goes to 8,388,607. Now, what I'm trying to get across to you here is using these sort of threads, the results can be totally unpredictable what's happening. All right? Because you have 3 separate threads, okay? And they could be accessing each other. There's no blocks on how they access each other. So all sorts of weird shit can be happening there. For instance, this I here should be going to 5 million, but instead it's going to 8 million, 8.3 million. Is that right? 607, yeah. It goes to 8.3 million. Now, as far as I know, it does that every time. So it's always 8.3 million. Now, why is it producing that? I don't know. All right. But this is the disadvantage of these sort of threads. All right. You don't have control over how many threads are going to be created. You also don't have control on how they're doing, what they're doing to each other. All right. So it can produce unexpected answers. They're all starting at the same time. Now they're going to run at different rates because, for instance, this one here is going to take longer to run than that one. It's going to take longer to run than that one, probably. It's not guaranteed either. Why? Because this is going over 5 million times inside the loop. Any questions on that? Now, the simple thing is, don't use those. Simple as that. All right? So the upshot of all of this is you don't use those guys. Now, what it does say here is, so this is used for any application that have many short-lived asynchronous tasks. Okay, now usually also there are going to be tasks that don't have any connection to each other. All right, now you could have a thread, one of these threads that's just connecting to a database. Well, then that's going to be fine. You could have another thread that's just getting input from a user. That's probably going to be fine as well. You're going to have another thread that's managing the color of your application. That doesn't matter on the application. That doesn't matter on the database connection. It doesn't matter on any inputs it's getting from a file. So it would be okay for that as well. So it's short-lived asynchronous tasks. Tasks that have to be carried out together, but they don't interact with each other. Yes? Okay. So the color of your GUI. Okay. Let's say if something that sets the color of your GUI dependent on the time of day. For instance, if you look on Windows there, you're able to see that once it goes after sundown, the blue light filter turns on your machine. Okay, so there's a thread there in the background that controls the color of your GUI. Okay, that does, all it cares about is the time. All right, all it cares about is the time. So you could imagine in certain situations that could use a new cache thread pool. It's only going to be used once, twice a day at the most. Okay. The font of your application might change dependent on the username. Let's say a perfect site, someone who, let's say John has got site problems. So when he logs on, it's going to see that John has site problems, a thread is going to run, it's going to increase the font by 50%. Okay, that's an example of when you use a new cache thread pool. So this is used for an application that may have short-lived asynchronous. So for instance, the color and the font when you first turn on your application, something like that. Okay, that may have short-lived asynchronous tasks at the same time. Okay, so now this will create a pool of threads of unbounded size. Now, and we'll create threads as needed. Now, what that basically says is you could have, how big is your pool of threads going to be? The answer is as big as needed. All right. So you could potentially have a pool of threads of thousands, millions. Okay. Which would be a terrible idea, but you can have it. Right. So this creates threads as needed. That's what what do I call them again? New cached thread pool does. All right. So it creates threads as needed. Now, as well, so goes along here. First task starts at that time. Second task starts. So that's the first one, second one, third one, but they all start at the same time. Okay. So all threads start at the same time. Okay. So this is thread 1. Time. And thread 2 starts at this time. Which is the same as thread 1. And thread 3 at this time, which is the same as thread 2. So they all start at the same time.
You would never use two tests in one test. The machine would never do that, would it ever?
Well, no, because a thread is made up of many tasks.
I thought might be my share of the test among certain threads, you know.
But here's the thing. Inside your task, you could have other threads. So yes, you could have another service.execute inside this service.execute. So yes, you could have a single task being divided up amongst multiple threads. Yeah, you can. All right. But you'd have to put it inside here. All right. So yeah, you can. But normally, but what you say is a thread is made up of many tasks, but a task can have threads as well. All right. Remember in Java, everything can go inside everything else. That's the basic rule. You can have classes inside classes, methods inside methods, whatever. Okay. Now,
What's the benefit of using executes rather than that?
Execute. What's the benefit of using execute? There really isn't any benefit to using execute at all, as far as I can see. There's a
Submit takes both and execute.
yeah.
Just to take one.
Execute in certain circumstances is faster. Only in certain circumstances, I think, Lisa. Okay, I don't know what those circumstances are. Now, there's a whole area of computer science about managing threads. Okay, I think if your task is small, I think execute might be faster. I think. I'm not too sure, but I'd advise you to use submit instead. Okay. Now, so where are we? So we're all grand here. Everything is going along here. Now, if we want to see how many threads have been used, all right? So if we want to see how many threads have been used, we'll go here. So we go amount of threads is, now the command is thread dot active count. Okay. Now something as simple as this, we should have the 3 of them are going to start at the same time. Okay, something as simple as this. So we should have 3 threads there plus the system thread. We should be getting 4. Okay, we're getting nothing. Let me just see now. So why? All right, now, so again, you can see what's happening here. Look at, see where it prints off? Up here at the very top. Okay, now, can anyone tell me why is that printing up there at the top? Now, even though I have this guy down here,
It's quicker. The system gets it there and the system quicker than.
because, yeah, right, but think of this way, right? So, we have got 4 lines of control going through the program, right? It's not, without threads, you just have 1 line of control, which is your system thread. Now, so we have the system thread. Now, the system thread in this method starts up here, then it does this, then it does this. Okay? Then it goes to the try block. Then it goes down to here. So, while the other threads are still doing its thing, the system thread is at here. So system thread goes banana, it goes to here. Now, thread 1 is only at probably this part by that time. Thread 2 is only at that part. And thread 3 is probably at this part, or just started to get to this part. All right? So the 4 of them are running concurrently at the same time. They're running together at the same time. The 4 threads are running together at the same time. So by the time our system thread gets to here, it's only just got to this part in this thread. It's only just got to this part in this thread. It's only just got to this part in this thread. Okay, so if you want this to appear last, what you have to do is here. So I am going to, so it's going to be outside server side execute. I'm going to put it in here, thread dot sleep. I'm going to sleep for 1 second. Now that is the system thread. So this puts the system thread to sleep for 1 second. And while it's asleep for that 1 second, all the other threads are going to complete. And then we should get this guy here printing out last. There it is. Amount of threads is 4. Okay, so this puts the system thread to sleep for 1 second. So I'll put it up here. And while it is asleep, all the other threads complete all the tasks. Okay, so this puts the system thread to sleep for 1 second. So while that's asleep, all the other threads are being executed. All right, everyone understand me so far? Yeah, because that is, so I need to make this code a little bit smaller, unfortunately. So you need to start looking in your screen. Now, so this is the system thread. Now, anything that's not a service is going to be the system thread. So that's the system thread here. And this is also the system thread. This is going to be T1 thread. This is going to be T2 thread. This is going to be T3. Okay, they all start at the same time. This does its thing. So system thread, T1, T3, all start at the same time. But as soon as it gets to here, what does it do? It goes to sleep for 1 second. And during that 1 second, T1, T2, T3 are going to accomplish all of their tasks. Any questions on that? Okay. Now, so that is a new cached thread pool that creates threads as used. That creates threads as needed. All right. Now, you don't use that. You only use it if your application is going to be using very, very short-lived tasks. That's not going to be used that often. All right. So, connecting to a database, connected to a file. You could use them for that. Okay. Now, so this command here, this is also a system thread. Which will only run after the thread.sleep 1000 command. Okay, so all the other threads will have completed by this time, so this will print last. Okay, right, so first type of pool is new cached thread pool that creates threads as needed. All right, don't really use that. Now, these next two ones, these are the ones you use. Because the first one, it's a bit bigger again. So this is static void. Okay, so 15, so 2 more. 17. So this is static void ex 15. Okay, so what are these guys called? These guys are called new fixed thread pool. Now, so what this does is takes a number of threads and allocates them all upon creation. Now, as long as the number of tasks is less than our number of threads, then all tasks will be executed concurrently at the same time. Now, if there are more tasks than threads available, then the task will be put in a queue. Now, what that means is, let's say we have created a new fixed thread pool of 10 threads. If we have 15 tasks, all right, the first 10 tasks are going to be put in 10 threads, and then 5 tasks are going to be queued. Yes? Okay, so i.e., we have a fixed thread pool of 15 tasks. Sorry, of 10 threads, and have 15 tasks. The first 10 tasks will be assigned to the 10 threads, and 5 tasks will be queued. Now, that's what's going to happen in reality. All right? You're not really going to have a thread for every task. You're going to have a pool of threads, let's say 15. Okay? Now, I wouldn't recommend you to have a pool of 15 on your machines there. I'll show you why in a couple of minutes. All right? The general rule of thumb is, make sure I have this right here. All right, so the amount of cores you have in a machine. So for every core you have in a machine, you should have 4 threads. All right? So this is a quad core machine, so that means 16 threads. I don't know, so maybe it's a dual core, it's probably on those machines. So you're talking about 8 threads. Okay? Now, so what you can do is, you can tailor the amount of threads running to the amount of cores that's on the machine you're running. All right? So there's only 1 core on those things. So it'll check to see how many cores, CPUs is on these things. There's 1 on them. So that means it's going to be 4 threads. If it's running on a machine like this, then it's going to use 16 threads. So it stands to reason it's going to be 4 times faster running on this than on this. Yes? That's one of the basic reasons when you see something, a game for instance, it runs a lot faster on this than it would on this. Why? Because it can be 16 times the amount of processing power on this than this. Okay? It's to do with threads. All right? Now, we are going to create threads. So this is new fixed thread pool. All right? So we are going to go Executor service. I spelled that wrong. Let's see. Service is equal to new fixed thread pool. So I'm going to say 4. So I need to import that. And it's all one word. Okay, hold on a second here now. Sorry about that. This lad. All right, so executor service is equal service is executor's new fixed thread pool. So that means it's going to create a pool of 4 threads. Okay, so that means you're going to have 4 tasks running concurrently. Think of it that way. Okay, you create a thread pool of 4 tasks. You create a pool of 4. That means you're going to have 4 things running at the same time. That's the best way to describe it. All right. Whereas with the previous version, you're not too sure how many things are going to be running at the same time. All right. You could have, for instance, 50 threads running at the same time, which is going to be ridiculous. All right. You could here end up with 50 threads running at the same time, which will put a ridiculous load in any machine. All right. Whereas with this guy down here, you're going to have a maximum of 4 tasks running at the one time. All right. So with a cached thread pool, you could have a huge amount of tasks running at the same time, which is going to put an inordinate load on your machine. In actual fact, it could lead to your machine locking up. Okay. Whereas here, the maximum amount of tasks that's going to be running at the same time is 4. Okay, so this guy here, maximum amount of 4 threads will be running at the same time, which means a maximum amount of 4 tasks will be running at the same time. Now, as you can well imagine, it's hard enough to keep 1 or 2 tasks figuring out what's happening at the same time. Imagine if you have 50 tasks running at the same time. All right? So new fixed thread pools are nearly always preferable to new cache thread pools. If you have something that's going to run really fast, 3 or 4 things run really fast, and you're always absolutely positive they're only going to run really fast, then you can use a new cache thread pool. But these are the guys you should use really. All right? So the maximum amount of processes that can be run at the same time is 4. All right? So you know that the maximum amount of threads that can be running at any point in time is 4. Right? If I run this application and all these threads are being used, how many threads are running in total? 5 and the system thread. Okay? Now, because I said it's never a good idea to have too many threads running on them, because remember, you're developing for everything. Okay? Now, to show you that they're all being used, so I'm going to put in a try block. Now, I am going to put in the try block and give me a second here. I'm just going to put in a final because I'm not putting in a sleep. And I'm just going to say if service is not null, I'm going to say service dot shutdown. Right. So I am going to put in 4 tests to start off with. So I am going to say service dot execute. I'm going to go runnable, very simple one. And then I'm going to say runnable service one time is, so I'm going to put in local time dot now. Oops, sorry. So put that in here. All right. So that's the first one, first task we're going to do. Okay. Next one is going to be a submit. It's going to be a submit with a runnable. And we're going to say here, this is first submit runnable time is time at now. Now I'm putting in the time here because you should see them all running at the same time. Okay. Put in one more. Service dot submit callable. So it's going to go in And I have that guy. I have that guy. I'm going to go callable submit, sorry, callable submit time is time.now. That's 1, 2, 3, 4. And I'm also going to, hold on a minute now. And this is going to be, and it's going to return null. And if I look at the employee class, okay, the dog class, for instance, dog class implements runnable. So that means you can do something like this. I can say service.execute.submit. And I'm going to put in new dog. And inside the dog class, I am going to put in the time. So time of dog runnable is local time.now. Now, so public class dog implements runnable, so that means you can do that. Okay, so that means the dog class has to implement runnable. That means it has to have a run method that returns void. It does. Okay, so when I run this, so this should give a time, this should give a time, this should give a time, this should also give a time. It should be all the same time. Do we understand that? Yes? All right, so I'm good. This is EX15. Okay, so all right, so we have different times, so different things are happening. Let me see if we can get the same time again. All right, so the first time they weren't all at the same time because something else was happening in the background. So it depends on what's happening in your machine at that point in time. So here we can see that they have started at the same time. I run it again. First time I ran it, 2 of them started at the same time. Another 2 started at a later time. So see if I can get it again. Now, 1, 3, 6, they're all starting at the same time. 5, 5, 9, 5, 5, 9. Okay, there. Create. The dog was created before the other 3 tasks ran. Everyone with me so far, yeah? Right. Now, as well, I'm going to see how many threads were used. Okay, how many threads were used? So I'm going to put in a catch block here. Now, so I am going to put the system thread to sleep here. I'm going to put it to sleep for 0.1 of a second. All right, and then I'm going to count thread dot active count. So while it's asleep, which is 0.1 of a second, that should be enough for all of the other threads to complete their tasks. Okay, so amount of threads in use is 5. Okay, 470. 8195. Run it again. 4075. 320. Run it again. 573. I'll keep running again until I see if I can get them run at different numbers. 734. 620. 580. Okay, so you can see that you have 4 threads and you have a thread for each task. Now let's say we have one thread that I'm going to put another thread in here. Okay, so I just set this thread 1. This is thread 2. Thread 3. And this is thread 4. Now, thread 1 carries out this task. Thread 2 carries out this task. Thread 3 carries out this task. Thread 4 carries out this task. So what will happen if we go, I'm going to change the employee class. Okay, so I'm going to have this implement the callable interface. Okay, so import callable, and then we just go add unimplemented methods. So I go in here, time in employee is local time.now. Now, so that means that we can put this in one of these lads. So service.submit. So I'm going to go service.submit. And it's going to be a callable. And I'm going to say new employee. Now, I'll run this now. Now we see something else happening here. All right. So what's happening here is that's one thread, that's one thread, that's one thread, that's one thread. This guy here has to wait until one of the other threads becomes available. Okay, so we'll run it again. See? Employee is always going to be after those 4 threads. Okay, so this is a 5th task. Okay, this is the 5th task. So this will have to wait until one of the 4 threads becomes available. So this task will always come after. So this task will never be first. Now, this task could start before one of these guys, but you'll always have something before it. You could end up with a situation like this, where let's say the time is going to be 74 for 2 of them, and then for this one it's going to be 75, and then the other 2 tasks are going to be 76 and 76. All right, now you've no guarantee that this guy here won't come before one of these lads. It'll usually, this guy usually won't happen until all the 4 tasks are completed, usually. Do not guarantee that, right? But there's always going to be some task before that guy. Okay, you could have a situation where that's task 1. That's task 2. This is task 5. This is task 3. And this is task 4. You could end up with that. But that guy will never be up here. It'll never be the first one. It'll usually be the last task. Usually. But not guaranteed.
Why is that? No, I thought you start that with the rest of them start it.
Because now, in this case, usually what you do is you match the thread pool to the amount of processors you have, right? So if there's only 2 processors in it, it can only be, if there's only 2 threads in it, it can only process 2 things at a time. Yeah? So these 2 will run together. But let's say if one service finishes before another service, it's going to start pulling in stuff. It's kind of hard to, yeah. Now, usually, vast majority of cases, this is going to run last. Okay? Because it can only run after a thread becomes available. Okay? So this will only run. So you have to wait until one of the 4 threads become available. So this task will never be first. It will usually be last. So it will usually, but not guaranteed, usually be last to complete, but not guaranteed. Now, it'll be last to start, but it might be the last to finish. Okay, so it will be the last to start, but it may not be last to finish. That's probably the best to say it. So it will be last to start. You fight. Sorry?
Why is it not counting it on threads you use?
Because we set it to be 4 threads. Okay? So there's only 4 threads. Now, this is the guide you use. Okay? Because by using this, you can set the amount of threads to be whatever the amount of processors there are on your own machine. How do you do that? I'll quickly show you how to do that. Now, I've already done it, but I'm going to do it again. So let's see. So if I go, so that's finally blah, blah, blah. So I'll go down here. So amount of available processors. Now I want to put in a thread.sleep here as well. Oh yeah, I have a thread.sleep, so that's fine. So amount of available processors. So we go, it is going to be runtime dot get runtime dot available processors. So 16. Okay, there is, that's the amount of threads you should have, that I should have. Okay, so what does that mean? I can do something like this. So I go int, I can say thread pool is equal to that guy. Okay, and then I can create a thread pool, one up here. And it's going to be, so now runtime.getRuntime.available processor. Runtime, that means wherever you're running your application on, whatever it's running on. So if it's running on something with only one CPU, which will be 4 processors, is the best way to describe it. So if you have a dual core, I think they're dual core machines, what you have there. Is that what it's coming up with a date?
No,
No. Yeah, so the dual core process. So that means 8 threads is the optimum for yours there. For me, it's 16. Okay, now, but by running this, the amount of threads is going to be dependent on your machine. That's what you use when you're creating threads. That's the guy. Okay, you don't determine them yourself. You should let the process. You should let whatever's running your code determine the amount of threads to be used. Okay, so you are, yeah. Sorry, it might run anything else, yeah. That is true. So what you could do is now it's not going to hog it totally, Andrew. It doesn't either, like it doesn't. Yeah, yeah. So half of them. Now, if you might want this application to totally hog the machine, yeah, you might. As you said, it mightn't be advisable. But here, for instance, that's only going to use half the available processors. Okay, so this will, but again, what you need to do in your testing phase, you would test this on different machines. Different machines with different processors. How do we do that? We would do that with Azure. We would create virtual machines in Azure. And you would test all this code on different machines. You would try it in something that's got only one processor, one core, 2 cores, 3 cores, 4 cores. Now, if you're running on a server, it's going to have multiple cores. So you need to test all those sort of things. It's relatively easy to set up in Azure. All right. Sorry?
I was looking at it the whole day.
Is it?
Yeah, it's very pricey.
Is it?
Yeah, the average, the default one they give you is like over 100.
Fuck that. But do you not get 250 hours free?
No, I think I need it anyway.
Jason, I think you do, Jason. Now you get 250 hours free, as far as I know.
Well, this is what told me with regard to the setup costs.
Bollocks that.
Yeah.
Well, I was told we'll find that out Friday. I was told you get 250 hours free. Where were you looking at the image thing?
Sending virtual machines, yeah.
No, but you know how you can create an image and you just install it in your own machine. You know.
Yeah, I was using the default ones that they give you default ones.
Yeah.
Like,
That's for creating the virtual machines.
yeah.
But you know how you can get images on your own machine and semantic ghost, you just click on it and you create a virtual machine on your own machine rather than creating on the cloud. Is there a charge for those?
Oh, sorry. You mean not using Azure at all?
Huh?
You mean not using Azure?
Yeah. Well, no, well, you use Azure to create the images for you and then you download them and you put them on your own machine.
There's lots of default.
Yeah. Yeah.
There's lots of other ways to have virtual machines.
Yeah,
They're
yeah.
free.
So now,
VMware and all that.
yeah. So this is going to create a thread pool of size 16. So this will create a thread pool of size 16. But this will hog the machine's resources. Now, we're not talking about the machine that is creating the code. We're talking about the machine that's running your app. All right? So, because it's runtime, we're getting the available processors when you're running the code, when you're running your app on whatever it is. It could be a phone, it could be a smartwatch, it could be Android Auto on your car, it could be anywhere. All right? So what this is doing here, this is creating a thread pool of whatever. So this will use all of your resources basically. Now, it doesn't actually use all 16 of them. Okay, there's other stuff. Windows is always going to prioritize itself over whatever it's running there. But definitely, if let me just see what I have here on this machine. That's process hungry. I have 2 or 3 games on here, and I know they're process hungry. They are hugely process hungry. They, in order for you to run anything with the games, it doesn't really run too well at all. Okay, so they're hogging your machine. They're squeezing all the possible resources they can out of your machine. All right, so what you would do in reality is you would test that on different machines, see how they perform. You know where it says on, you used to buy software in the old days, it'll say minimum specs required. It'll say you need a dual core processor. If it says you need a dual core processor, that means your application is running 8 threads. All right, that's how they get the minimum. That's one of the things how they get the minimum specifications, is the amount of threads that are being used. Okay. Now, as I said, this will create a thread pool of size 16. This will hog machine resources. Okay, sorry, this can hog machine resources. It may or it may not. All right. So if you want to, you could do something like this instead. Thread pool divided by 2. Now, in your case, it's going to be 8 and 4. But this is a way for you to tailor the amount of threads used dependent on the machine that's running. All right. So you're getting here into the realm of tailoring your code automatically to whatever it's running on. It's the first time we've seen this. All right. So this is automatic tailoring of this guy, or of this code, to meet this guy, to meet whatever machine it's running on. Okay. Any questions on that?
That line 937 basically, instead of writing everything again for like 1 thread at a time, one machine.
Right. So this is a thread pool of 16. Yeah. Okay. That means you can have a maximum of 16 tests running at the same time. Okay. This one here, this is a thread pool of 8, which means you're going to a maximum of 8 running at the one time.
Yeah, that's what I mean. So that basically that 937 is so you don't have to do all over again for just.
But no, it means that it's not going to hog all the machine's resources. That's what that is. So half of it is going to be left over. You can do other things. Whereas if you use this, it could hog your resources. Now, with Windows, it doesn't really hog your resources because Windows is smart enough and it does all this management stuff. All right. But for the likes of these, it doesn't really. So would make a difference on Android, on watches, on Android Auto, so it makes a difference, I believe. Okay.
You said 16 threads to run on your machine. Or
at the same, well, 16 tests run at the same time, yeah.
16 thread. Does that include the system thread, or is that
No.
include the 16, or is that separate?
No, separate. Yeah. So.
Yes, no.
Say that again. Now, 16. No, it doesn't include the system thread. Okay. So if I go at that point, if I go. Now, this guy is only a pool. They're not actually used until you use service.execute or service.submit. Do we understand that? All we're saying is that you can have a maximum of 16 tasks running at the same time. That's all that says. Now, there is none of them being used at that point in time. Okay? The only ones that are in use is the 5 threads we've been using already. Everyone with me so far? Okay, so this, so put in here, this does not actually use threads. This merely says we can have a maximum of 16 threads running at the same time. That's what it means. Okay, so or a maximum of 16 tasks can be running at the same time. Now, you've got to ask yourself, do you want your application doing 16 different things at the same time? It's a lot to take account of. It's hard enough to fucking take account of one thing. Never mind 16 different things happen at the same time. If you're sure that those 16 things aren't interfering with each other and we're going to be doing with synchronization, that's what synchronization is all about, making sure that only one thing can be accessed at a time. If you're sure, then yes. So if you have 16 threads running, your application can be more, it can be more than 16 times faster. It can be thousands of times faster, right? It can be tens of thousands of times faster. It can be millions of times faster, all right? So it's more than 16 times faster. It can be hundreds of thousands of times faster, all right? But remember, that means you have to keep track of 16 different things at the same time. So let's say you had a software development company and you had 32 software developers and you had 16 threads. What would be a logical way to divide out the work? Right. If you have 32 software developers, right? No, fuck it, forget it. Never mind what I said there. Never mind what I said there. I was talking through my heart. I don't know what I was talking about there. Okay, right. So, okay, try to pull it like to this kind of how. Merely says you have a maximum of 16 threads at the same time. Or a maximum of 16 tasks can be running at the same time. All right. So that's all that really does. It means that. So new fixed thread pool. That means you can have 16 threads running at the same time, but no more. So if you have 18 tasks to perform, the first 16 tasks are going to be performed at the same time, and there's going to be 2 are going to be queued. Okay. Now you can set priorities on the queue, which we will be doing in section 7.6. It's called forking. Okay, which is great crack entirely. Now, there are different options with forking. The easiest option with forking is just let Java do it for you. Simple as that. All right. But now,
You could have obviously different services there and different tasks.
Oh, yeah.
It's all managed. Yeah.
yeah, it's all managed. Now, but with new fixed thread pools like this, all of the tasks have equal priority. All right. Now you can set priority threads. All right. You can set priority threads, but let's just say if you just create a new fixed thread pool, you have 32 tasks. The first 16 tasks now, the first 16 tasks are going to be processed by 16 threads, and the 16 tasks going to be in the queue. Okay. And as threads become available, the tasks are added to them. That's the way it works. Is that okay? Right. Now, so this guy here, this 50 task with the wait. So now, so the last type of pool thread is this guy. So this is static void ex16. So this is the last thing in this section. So this is, it's a new scheduled thread pool. Okay, now what is this? This is the same as new fixed thread pool, except it returns an instance of schedule Executor service, which means you can schedule tasks. Okay. Now, so you've seen the new single. So I'll just go up here again, scrolling up, scrolling up, scrolling up. It's a new single thread scheduled executor. Okay, so it's to say it's a cross between that and a pool. Okay, so it's a pool of those guys. Okay, so a new single threadable executor. This is a pool of scheduled executors. That's what it is. Okay, so
They're the ones that return the future object.
yes, they return a future object. Okay, so we are going to go executor service service is equal to, so it is executors dot new scheduled thread pool. Okay, so we're going to say a size of 10. Now, I am going to create, now, just like with the schedulers, it can only take a runnable, okay? This guy can only take a runnable. So I'm going to create a runnable outside here. So runnable task 1 is equal to. Now I'm going to put in a counter inside here as well. Int counter is equal to 0. So I'm going to say task 1 number is, I'm going to go plus counter. Oh fuck, hold on a minute. It has to be final, so I need to take that guy out of there. So I have previously I have a variable called count, a static variable, so I just go count is equal to 0. So this is going to be count. All right, so I previously have a static variable called count. So count is equal to 0, so I go plus count. Now, so we're going to say, so this is which is a new scheduled thread pool. It's going to have a maximum of 10 threads happening at the same time. So I'm going to go service dot Service dot SC. Do this. So I need to hold on a minute. There's something wrong there. Give me a minute. All right. This is wrong here. This is scheduled executor service. Jesus. All right. So scheduled executor service is equal to executors.new scheduled thread pool. Okay. We've seen these guys before. These are about if you want to run something in the future. All right. So that's the service. So these are tasks we want to run at some point in the future. And what we're going to do, executors.new scheduled thread pools, that means it's going to pull from a pool of 10 threads. So this guy here, so it's going to run task 1. Now the lead-in time for the first task is going to be 3 seconds. And from that point onwards, it's going to have a gap of 2 seconds for each move. Okay? Now, if I run it just like this, if I just run static void ex16, I just want to start running it. Now, just a quick question before I run it. How many times is that going to run? Now you're going to have 3 seconds before it starts. Okay? Then it's going to start, and at 2 second intervals. How many times is that going to run? Once? 2? 11? I can see where you're getting 11 from. Yeah, I can definitely see where you're getting 11 from. Okay. Okay, so she's going to start now. There she is. 3 seconds is up. 2 seconds. It's going to go infinitely because I haven't shut it down. Okay. Now 11, because you've got 10 thread pools plus the 1 system pool. So after lunch, what we're going to do is, as soon as all our threads are in usage, it's going to shut itself down. Okay. The bat's going to keep on going forever, which, you know, isn't such a bad thing. And also, here's the beauty of this one, right? This is going to keep on going. But there's only going to be 10 threads in operation at any one time. If you use the cached thread pool, okay, if you use the cached thread pool, it would be creating a task, a new thread every time you run this. So if it runs for a minute, it's going to have created 28 threads. Run it for an hour, it's going to almost 2,000. Okay, but this way here, you're sure that only 10 threads are being in usage at any point in time. Okay, so I'm going to stop it, and we are going to go to lunch. Okay.
So that period there, that's best case scenario for 2 seconds.
Sorry?
That period, it's the best case scenario.
Yeah.
For 2 seconds.
Yeah. If any of them, remember before, if any exception happens, it becomes a repressed exception. Or repressed? Suppressed exception. Repressed is a different thing entirely. Okay. Grace Catholic, you know. You'll go to hell. that train is going to hell. What's that? What's it? What's it? North or south?
No,
Okay.
Holy key.
Huh?
Ah, well, yeah, thanks, Dad.
move your hands too quick and the sanitizer will all end up on the ground.
Are you serious?
You told me. You should have told me that. Huh? Well, now, if I put a request in now, I'd say you all should be dead by the time they come through.
Maybe with those seats, they clear.
I'd say nothing. I could say something now, but I won't.
Were you too?
No, Jesus, good win though.
I was there. Playing excellent football. That was it.
Jesus Christ, I don't know. Telling you. Saw the first half. Did your man deserve to get sent off?
And he did, yeah, he did. He kind of, his elbow was raised. No. Coming in, also, he put the top of the man on the head.
Yeah.
It was.
Kind of hard to see on the television, really, no?
Yeah. It looked. I was at the back of the window, so I couldn't see quite how head on, but I saw this match on the.
Was it full opposite the stand side? You know, the terrace.
No, it wasn't.
But there was a lot on the stand, and
Oh, that side was.
Yeah.
The other wasn't.
I can't understand putting seats in where you be no cover though.
I know, yeah, well, I think maybe there won't cover up there.
And they should have the chicken shed. I don't want to get rid of that chicken shed though. It looks terrible.
Yeah.
And the toilets. Ugh. Oh shit, I never fucking stopped that.